and thanks for joining. Today I'm going to talk about real-time stream analytics, right? We've all heard of stream analytics, but today I'm going to specifically talk about how tools like Kafka, Materialize, Rising Wave, and KsqlDB basically fit in stream analytics, right? So my goal is basically to make this session simple for you guys, a little practical too through a demo, and maybe even a little fun. So stream analytics, right? Think of it like the difference between checking yesterday's weather report in newspapers versus seeing a live radar map of storm moving right now, right? We've all seen that. We've all been there, and we are all surrounded by streaming data every single day. Be it rides on Uber, be it your payments on UPI, maybe messages on WhatsApp, live scores for your favorite sports, right? Stock trades, or even this Teams call that we are on right now, right? You're all streaming this Teams call right now, and all of it is constant flowing data, right? So the question is, how do we capture this? How do we harness this stream, right? Analyze it and act on it as this data moves, as it happens, right? So that's what this session is all about. Moving on, right? Here's what we'll cover, right? First, a quick intro to stream analytics and why it matters. Then we'll look at the main tools that I just talked about: Materialize, Rising Wave, KsqlDB, and Kafka as their backbone, and what makes all of these tools unique and different from each other. And after that, I'll share some real world applications from industries where these tools are being used at the moment. And finally, we'll wrap up with a quick demo so you can possibly see all of this in action, right? Right. So let's start with the basics. What exactly is stream analytics? At its core, it's just about analyzing data as it's being generated, not hours later and not the next day, but right in the moment, right? Imagine if you have a imagine if you were a stock trader, right? Most of us are stock traders these days, but imagine you're a stock trader and had to wait until tomorrow to know today's prices. You'd run out of business. And same goes for Internet of Things, IoT. Think about your fitness tracker or your smartwatch, right? You're going on a run, and if your heart rate spikes abnormally while you're running or while you're working out, you'd want that insight then and there, right? Not in a weekly summary email saying, well, your heart rate was wonky. That does not work, right? Traditionally, we've all done analytics in batches, and some of us still do. And for example, you collect all of sales data, and you run a report on it the next day, right? The downside is that data is stale, but with streaming, you don't wait. The data is processed continuously as it arrives, and this slide depicts just that. You've got batch processing on the left, you've got stream processing on the right? You can see that D1, D2, D3, D4 represents chunk of data, and it's being processed in batches, being hit to the processor, and then a report is being generated. But with stream processing, it's all continuous. You've got a stream of data flowing into your processor, and you're just generating outputs through it that way, right? So this is a slide that just covers what I've just gone through. The difference between batch and stream processing. Quickly glance over it. Uh, right. So why does it matter, right? Why do we need stream analytics? It matters because time is value, speed is value. We've all heard that, and fraud detection only works if you catch it before the transaction clears, right? The you don't want the criminal to get away with faulty transactions or anomalies. Uh, Customer personalization also works best if you show the right offer while someone is still browsing and not after they've left. You want to make that purchase then and there. And honestly, I'm sure this has happened to most of us. You're searching for something online, or maybe just thinking about buying new shoes, right? And boom, suddenly every website you open is showing you ads for shoes before you've even closed the tabs. And I know it's creepy, but it's also a perfect example of how real-time personalization works, and how every industry is now harnessing the importance of streaming data and building their analytics pipelines on top of it. Moving on to the tools, right? The tools that we want to look at to basically make all that we have just talked about possible. We need tools, right? We need a backbone that can handle these endless events, these endless streams of data that I just talked about. And that is where Kafka comes in. And Kafka, I like to think about Kafka as highways of data. It moves millions of events in seconds, per second, or maybe even reliably. It's very scalable and also fault tolerant and widely adopted too, right? So almost every big enterprise that I have personally worked with as a data engineer has had Kafka running somewhere to power their real-time use cases. So Kafka is everywhere. But Kafka by itself doesn't tell us much on its own, right? We need tools to harness that stream of data. That stream of data is not useful on its own, and that's where the other tools come in, right? The ones that I just talked about, KsqlDB. That's a database that's built on top of Kafka. It sits in the name KsqlDB, right? Materialize. And then we've got Rising Wave. All of these actually sit on top of Kafka or maybe other pub/sub systems, and they process this data and turn it into insights so you can actually use them. And each has its own unique speciality, and I'll break them down one by one and tell you how they differ from each other, right? But before we actually dive into the tools, let me quickly show you what a typical stream analytics pipeline looks like, and where these tools that I've talked about actually fit in, right? We've got KsqlDB, we've got Materialize, Rising Wave, which is confusing. We've got a lot of tools. Um, at a high level, if you look at it, this is a high level diagram, right? The one that we're looking at. We've got a source, we've got a processing engine or a processing pipeline, and then we've got your outputs, right? A three component system. And so your source is where Kafka comes in, right? It's responsible for capturing those events that we're talking about. We're calling it stream, capturing that and then transporting it to your processing engine where all of your tools fit in. So this middle part here is where all of your tools fit in. You've got KsqlDB, Materialized, Async. These are used to stream, these are used to transform, aggregate data, right? So data processing, that's in the name. And then you've got your sinks, which we are calling outputs right here. So you could have your dashboard as your sink. You can harness alerts. You can have APIs that are being used. So APIs would consume from your system, and you've got your storage too, right? So you could use storage as sink and store all of this analytical insight data that you want to store. So this is a simple three component pipeline. Okay, now, right, the difference between the three. If you're building real-time applications directly on top of Kafka, right? If you're building real-time applications directly on top of Kafka streams, KSQL is your best bet because it's tightly coupled with Kafka. It's in the name, KsqlDB. So Kafka SQLDB, right? It's in the name. And so you typically use that for such use cases. And if you need live dashboards or maybe instant alerts, then Materialize is your choice, right? It's built to give you that sub-second query results without having to use complex pipelines. So you use Materialize there. And it's also in the name because it says Materialize and it's built on top of materialized views. I'll talk about the difference between normal solid views and materialized views in a bit, but that's what Materialize actually does. It's built on materialized views. And then you've got Rising Wave. So if you're tackling huge volume of events at scale, we're talking basically millions of records per second with heavy duty analytics. And if you need complete cloud support and you don't want to have to manage the infrastructure, then Rising Wave is the tool designed for you. But bear in mind that Rising Wave comes at a hefty cost, right? Because it's a fully managed platform. So yeah, to summarize, think of it this way: KsqlDB for app logic, Materialize for dashboards, and Rising Wave when you want to use stream analytics at scale. So alternatives to Rising Wave, right? Materialize is a good alternate to Rising Wave. Rising Wave is hefty and costly, like I said. But if you want to still manage your infrastructure and still want to use GCP and AWS, right? If you want to use your cloud platforms, you can still use Materialize. So you can have your source as Kafka, or maybe your source as PubSub if you're using GCP. Your processing engine for your stream analytics as Materialize because it's cheaper, but you'll have to manage that infrastructure, and then you can use your sinks as your dashboards or anything else, right? So Materialize is a good alternative to Rising Wave. And if you want to stick to the cheapest way, right, and you're running on a say a cloud era platform, right? So all of your legacy platforms where you using Hadoop and HDFS and Kafka, you don't have cloud there. So then you can use KsqlDB, right?
For suppose if we are using cloud
Got it.
and we are working in a microservice environment, which one we
Hmm.
can go for?
You can still go for Materialize. If you're working with Azure, GCP, AWS, you can go for Materialize.
And for this, do we need any extra configurations required?
You don't need any extra configuration is required. Materialize is an external platform, so you can containerize your application. I'll just show you that in the demo. You can containerize it and harness Materialize directly, but you need your stream to be active, right? So if you're using GCP, like I said, you should have your PubSub ready, or maybe Kafka connectors ready. And if you're using AWS, maybe have your queues ready. So you need your messaging queues ready, and then you can harness Materialize that way.
Every different streaming tools, it's a purpose of like uh, Kafka,
Mhm.
right? How it will this will be differ in their function, means function.
Right. So okay. So I'll go back for a sec. Right. So Kafka is backbone for all of these three tools. So any of your messaging queues like Kafka, right? Kafka has topics, and it's got topics, right? So it can act as your subscriber, and these tools can then act as the subscriber for that Kafka topic, and your Kafka topic can publish messages to these tools. So Kafka acts as the backbone for all three, or you can replace Kafka with any other message queue, right? So you could use PubSub. You could probably use your other queues that you have available on AWS, and just use them for streaming, and use these for analytics. These are analytics tools, and these don't produce streams, right? I hope you understand that. So Kafka for producing streams, and these tools to run analytics insights on top of those streams. Does that make
Analytics.
sense?
So
Yeah.
one thing I want to know. So Kafka is used for streaming purpose, topics and to get the live stream data.
Yeah.
Um, so so analysis purpose, these tools which you are showing like KsqlDB, Materializing,
Correct.
Rising Wave, these tools for
Yep.
analytic purpose. So what is the how it will be useful this analysis, and what data it analyze actually? So
Yes. So you've got, say you've got stream, right? You've got a stream
so
of
could
cricket.
you take one example? I will make me
Yeah.
correct or explain in that way. So there is
Sure.
one
Okay.
request comes. The
Mm,
request requires some data, and
mm,
uh, or this request is going to update something in the backend. So that update will be used by under microservice. So instead of hitting the db, the again it will directly fetch from this Kafka topics, right? It will be notified, the other system will be notified and fetch the
mm.
data from this Kafka. So
Yep.
likewise, in here we use different kinds of Kafka providers, like I mean Kafka functionality. So how analytics will be useful here in this scenarios? Can you
What
explain in that
what
way?
you've Yeah, what you've talked about is sort of an event-driven architecture. In your use case, you are using Kafka to trigger events, or maybe you're using it in the app logic, right? But say your Kafka actually contains valuable data. For example, Kafka has data being streamed in. Think of Amazon, right? There's multiple users purchasing stuff, right? Now, all of that data is being fed into Kafka. So you've got consolidated data set of all of the users purchasing XYZ, right? You've got all of that in Kafka, but you don't get any other information from that stream. You just know, well, this user purchased X, this user purchased Y product. But what you want to actually understand is how many users in a 30-minute window purchased, say, X product, right? You want to do that analytics on top of that data stream. How do you do that?
Okay.
Right,
Okay. Okay.
you need to build a system on top of Kafka that does that for you. That is where KsqlDB Materialize and Rising Wave comes in, right? So
Okay.
you
Okay.
need to
So
harness that stream and yeah, and draw insights from it.
KsqlDB is for SQL DB, and this is Materialize for PostgreSQL. Is like that.
Yeah, so KsqlDB uses Kafka SQL. It's similar to SQL. Materialize uses Postgres. So again, it's also quite similar to SQL. And then Rising Wave is cloud native, right? So you can use either GUI. So you can use graphical interface to harness this and build your analytics pipeline, or you could use SQL there as well.
Okay, we use any one of these three, right? I mean,
Yeah,
whatever
you could
the
use any
according to
one
our
of these
requirement.
three according to your use case and according to your cost, right? Materialize isn't costly, KsqlDB isn't costly. You can just pop these right up in your systems. Rising Wave is costly, so you'll probably need, money to do that. But
Okay,
all of these three serve the same purpose. It's just the difference in the amount of data that you are processing and the latency that you want from your system.
so
We will talk about that in a sec. The
okay,
latency and
list one now,
yeah,
one question,
sure.
one query I wanted to ask. So where we will configure these things actually in the Kafka directly in the code, they will means developers implement the topic names and everything. So these
Hmm.
configuration external analytical purpose, how where we will configure this one.
Okay, I can show you that through my demo. Once we go into
Okay,
the
okay,
demo,
sure, sure,
I'll
sure.
show
Okay,
you
please.
that. Yeah, we'll create
Okay,
a
please
topic. We'll
continue. Okay.
yeah build these on top of it. Okay, I'll move ahead. We were. Uh,
Just
let
a
me get back
question
to.
before you move ahead in this slide, if you
Yeah,
allow me.
sure. On
Yeah,
this
the
one,
difference
right?
between KSQL and Materialize. And,
Mm-hmm.
and suppose in the same scenario that you just mentioned,
Mm-hmm.
suppose to augment the data, I need an
Mm-hmm.
external source. So say the customer are not there. So I need the list of customer who's
Okay.
purchased this X item, for example. So I need to
Mm-hmm.
provide them with any of the dimension of the customer. And the customer information, suppose that the customer information is in Redis database or Oracle database.
Right.
So is this scenario supported by KSQL Materialize? I believe from
So
KSQL, as far as I know, it's not, but Materialize,
it's
I
not.
have no idea about.
Yes. No, even Materialize. So KSQL also runs on views, right? So you'd have to create a view of the data that you want to use, and then you've got your other data set lying externally, and you want to join with it, right? So you'd have
Yes.
to then sync that data into, whatever system that you're using, right? If you're using GCP, you'd have to, write that view into BigQuery and then, join with it. And with Materialize too, as far as I know, you'd still have to write it back to BigQuery if you want to join with external data sets.
I can bring it to BigQuery as well, but the question is, does the KSQL goes out of the scope of Kafka and get the data from external, any
No.
external?
No, but yes, Kafka, you cannot do it. It stays inside Kafka, KsqlDB. And then I'll take questions in interest of time. I'll take questions in the end. Thanks. Okay, right. So Yes, this is where we were. We were talking about KsqlDB versus Materialize versus Rising Wave, right? And like I just mentioned and just answered some questions. Materialize views are optimized for analytics and dashboards. So Materialize, you're going to use it when you want to build dashboards and you want to run analytics quickly. So subpar latency, right? Uh, Sub-second latency, sorry. And this means that you can run complex queries, joins, aggregates, filters, and Materialize would keep those results fresh automatically. So whenever your dashboard queries it, the answer is already computed for you. That's what a materialized view is. It's already computed, so you don't have to run that query every time, because that's how views would work. And then you would get your sub-second results even on big data sets. So this is just another feature comparison between all three. One is cloud native, and one is very low second, very low latency, so sub-second latency, and differences between how you could scale all these three. So let's have a look at the cloud native view of it. And so this is where we are. This is what I was talking about. I'll run through this again. Like I said, Kafka, KsqlDB, basically when you have a managed Kafka service like Confluent Cloud, or be it your Cloud Era service with Kafka attached to it. Materialize, when you're working with cloud providers like AWS, GCP, Azure. Rising Wave, when you have a fully managed cloud native platform, that you don't want to manage, you want all of the infrastructure support externally. So that's when Rising Waves comes in. Basically, what I'm trying to say is the industry trend here is overall clear. Cloud native, elastic, and pay as you go streaming platforms are becoming the standard now. So no one wants to maintain heavy infrastructure, and if the cloud can scale it for you, then why not stick with it? Right. Moving on to the next one. So why is Materialize best for live dashboards? Because Materialize is all about instant queries, right? So it's like having a cricket scoreboard that updates the second the ball is bowled. So it'll update that very second. And analysts can keep using plain old SQL, and dashboards will still update automatically as events arrive. So it's not complex at all. So you don't have to build a complex pipeline, unlike Rising Wave. And again, it's simple, it's fast, and it's perfect when you want dashboards or alerts that are always fresh. So no refresh buttons needed here. I'll showcase this through a demo just in a bit. Bear with me for a few seconds now. Now, right. So Rising Wave for streaming at scale. Rising Wave shines when the volume of data is massive. So think of IoT sensors sending millions of events per second, right? Or maybe even clickstream data for an e-commerce giant. I just took an example of Amazon. So right, something of that scale. It's built as a distributed system. So Rising Wave is built as a distributed system, and scaling happens on compute and storage horizontally. So you could scale it horizontally as much as you want, and it's again fault tolerant, quite obviously, because it's fully managed. So you don't have to worry about managing the infrastructure yourself. And again, it's cloud native too. So in short, Materialize for dashboards and Rising Wave for fully managed big data streaming analytics at scale. So yeah, this slide actually summarizes all three: KsqlDB, Materialize, and Rising Wave. There's a quick chart here that shows you the difference between the attributes of all three. Right. Okay. Yeah, so these are industry examples and use cases. We've picked a few of them while we were going through the slides. KsqlDB, maybe in gaming and sports, when you want real-time leaderboards that updates player scores, and maybe you want to push alerts into a Kafka topic. That's when KsqlDB comes in. If you want to run analytics of that scale. Materialize when you want dashboards, so update instantly as transactions stream in, right? And Rising Wave, again, we took an example of IoT sensors and e-commerce. that's when you want to use rising wave. So basically, if I'd like to wrap it up, then I'd say stream analytics is about turning data into insights while it still matters. Again, Kafka is the backbone, so don't think of Kafka as your analytics tool. It's still the backbone that harnesses the stream. And then you've got tools on top of Kafka like KsqlDB, Materialize, and Rising Wave that gives us different ways to act on that live feed. So at the end of the day, it's all just about one thing: making these decisions faster. So that's exactly what it's about. Now the demo, I'm gonna start up a Kafka stream with dummy data, so we could harness this stream, and then I'm going to use KsqlDB, and then I'm going to use Materialize, and we'll try to visualize it using an open source dashboarding software like Apache Superset, and see how it all ties in. I'm not going to cover Rising Wave because it's a paid platform, and we've only got time for these two anyway. So let's quickly move on to the demo. Okay, good start. So I'll quickly run over the tools that we're going to use, and you're going to need to do this. You're going to need, a engine to, deploy images. I'm going to use Docker Desktop to do that. So containerize images and deploy it. That's what I'm going to use. Since it's a local setup, I'm going to use Docker Desktop. And then you just need your IDE to, compile all of this. So first, we're going to run through KsqlDB. Right? I'm going to clear all of this to start again. Right, cool. Now again, we're going to create another topic, right? Kafka is the backbone for Materialize as well. So just like KsqlDB, Kafka, we need it. We need it here. We are creating a topic called clicks again, right? Same configuration. And we have created a topic called clicks, right? Again, it's bare bones. It's not being fed with data at the moment. It's empty. So we need to do that ourselves, right? Now we're going to list this topic. This just lists the topic that are on this container. Says yes, we've got topic called clicks here, right? It says clicks here. Okay, so yeah, we jump to this. So what we're gonna do is we're gonna pull up Materialize now, just how we pulled up KsqlDB. Right? What did it say? Oh, it says not running. Okay, let me Docker compose up everything up again. CD Materialize back in here. Let's see if it lets us harness it. Right, we are back into Materialize. Now all you need to do is one extra step. You need to create a connection to that Kafka broker, right? Because we need to connect to that Kafka topic. And Materialize, since it's not integrated completely like KsqlDB, you have to make that connection to the broker. So this is one extra step that you need to do when you need Materialize, because it's an external system as opposed to KsqlDB. Right, we're going to create a source called clicks raw. So I'm following a bronze, gold, silver architecture. If you're data engineers, you're probably aware of that. We're going to create a source called clicks raw, and this is going to be your JSON envelope, right? So it's going to be your JSON formatted file for what we were trying to do. So user page timestamp, it's going to be JSON, a semi-structured data set for it. So we're calling it clicks raw. That's why we're calling it clicks raw, because it's raw data and we cannot work with it as is. Right? We've created that source, and we're going to see if it's got data. So it's got data, right? For the sake of this, I've got different users for Materialize. We've got Alice, Bob, Carol, Dave. They're trying to do the same thing. They're trying to visit these endpoints, home, shop, about, cart, right? And we're just trying to harness all of that. this query only selects 10 out of well, as many as possible records. So it's been running from inception again, right? So this data publisher.py does the same thing, keeps on running, keeps on feeding messages into a topic called clicks at 1 second interval. So it's doing the same thing. Now we're trying to create a materialized view on top of it. So this will store all of my JSON data. That was my raw data. It's going to transform it. As you can see, I've got transformation query right here that says, cast user from my data as text, call it user ID, cast page from my data as text, call it page, and then timestamp as digint, right, as TS timestamp, right? And then my object was my JSON object that I was trying to consume from ClickSraw, right? So this will create a view that I can actually use as opposed to this semi-structured data right here. What I'm going to do is I'm going to select my user account just to see if it's working. So since it's a materialized view, you cannot query it. You cannot run it in real time, right? Because it's a view. So you'd have to query it every time you want to pull data out of it. But as you can see, it's being fed in with new data every time. So Dave's count increased, Carol's count increased. So every time I query it, it would increase, right? Increased again. So that's because users are making clicks in real time. Now, the next part is to actually set up a dashboard on top of this so we can actually visualize this data that I'm seeing right now, right? We want to visualize it. How do we do it? Because Materialize ties into visualizing tools seamlessly. We're going to use Superset here. That's another open source dashboarding tool, Apache Superset. We're going to use it. So for the sake of this demo and to save time, I had already created a user called admin, had the password admin, right? Email, blah, blah, blah. So you have to do this configuration setup every time you want to run it. Well, not every time you want to run it, but the first time you want to run it. So it stays on. So it'll say user already exists because I did it for the demo already. But if you're doing it for the first time, you'll have to create it. Now again, just like I pulled up Materialize, I'm going to pull up Superset, right? We want it running, and then we want to initialize it. Again, this command just initializes it, so it does just that in it. Right? Once it's initialized, what we want to do is we want to install a Postgres client on top of Superset because Materialize runs on Postgres. So we need to support all of the materialized libraries, we need to install Postgres on it. My bad. I think I did not execute the bash script first. We're going to get into bash and then we're going to install Postgres. It's doing this all in the subnet, right? So it's going to be a local setup. It's doing all of this in subnet, installing all of these libraries in the subnet. So once I go to my local host, I should be able to see the dashboard. Okay, now localhost 8088, like I just said, I should be able to see it all. Let me get back to this. Should be able to see Superset in here. Let me log out just for the sake of it. We had username admin, we had password admin. So this is where you land for the first time once you're setting it up. The Superset login page. You log in, right? And then you will go to your data sets. I already have 2 data sets assigned, right? But you can come in here, click on add data set. Obviously, you'll select Postgres SQL because that's what Materialize uses. You're going to use public here, schema is public, and then you will select either of these, right? So clicks raw, that's your raw JSON data. We cannot use it to generate dashboards because it's semi-structured, but you want clicks view here, right? It'll refresh the columns. It'll say it's got user ID, it's got page, it's got timestamp. That's what we had. So it means all of it is working. Now, once you have your data set assigned, you want to create a dashboard on top of it, right? So once you click on dashboard, it's pretty nifty, right? And pretty self-explanatory dashboard, right? Click on add dashboard, create a new chart. For this demo, I'm going to create a bar chart. And all right, oh sorry, you need to assign a data set, right? We've got two data sets. We've got clicks raw, right? We created clicks raw, and we've got hold on, yeah, we had clicks raw, and we've got views, right? Clicks view. But we're going to use clicks view because it's the structured data that we want. We structured it using this query. Now, once you have assigned that data set to your chart, you're going to click create new chart. Again, for this, we want to calculate the metric of how many hits a user made, right? So user ID is going to be my x column, x axis, and the metric that we want to calculate is the count star of user ID, right? So how many times a user hit a particular page. This is what it's going to do. So y-axis is going to be my metric. Once I click on create chart, right, you can see x-axis is my user ID, Alice, Bob, Carol, Dave. These are the number of hits they've made, count star, right? 0, 30, 60, 90, 120. That's the interval that we're using. And as you can see, Alice made 120, Bob made 146, 125, 99, right? One second, let me hide it. And then if you want to refresh this dashboard, just create on update chart, or maybe you can create a real-time dashboard too, right? Through superset, right? Update chart, and it's going to update it. So 148 went to 134, 109, update chart, 1010, 135, 150, right? It's updating in real time. So this is how you can still visualize all of that data stream that you had streaming into that topic using Materialize. So I think that's what we had time for. We have already overrun 2 minutes, but I hope this was a little useful, and I'm going to share a GitHub link of all of this code so you can use it yourself, right? Replace some of it and possibly get started with real-time stream analytics.
For Materialize, does it store the views separately? Like for KsqlDB, I think you mentioned that because it is just processing in real time, it doesn't.
No, it does. KsqlDB does. You just have to create a materialized view on top of KsqlDB.
Okay. Okay.
Yeah.
And
So if you create a view, it'll store.
Materialize does that on its own, like.
Yes. Materialize would do that on its own. That's what basically its MO is. So yeah, that's what people buy it for. It'll create a materialized view, and then you can run dashboards on it.
Got it.
Rajat, Yatha this side. Can you again show like how that materialized view was connected to that superset? Like how was it directly streaming up?
Yes. So it's all in the config. I'll quickly show it to you. Right. So step one, we connected Materialize to Kafka. That's where this happens. You create a connection between Kafka and Materialize. Step two, you need to connect Materialize to that, right? So here's the connection string. We've got Postgres Materialize. This is the port that we were running on, right? And this is the localhost.
Okay, so whatever view that we were creating, that would be directly like set.
Yeah, all of the data sets, not just the view, all of the data sets. Yeah. We saw clicks raw in there too, right? So we saw clicks raw in there. You cannot harness this data. So if I were to create a chart out of it, it would make no sense. But yeah, anything that's created on this connection can be streamed into Kafka, because that's where it's listening, right? It's listening to the materialized container. We created this, right, called materialized, this bit right here, materialized.
Okay.
Right. So anything that's inside this container, it's going to listen to that.
Does this all work only on structured data, like JSON or some format?
I mean, it depends on what you're trying to do again, right? If you're trying to create a dashboard, you obviously have to structure it. You cannot, create a dashboard out of this, right? For the sake of it, I'll show you. So I go here. My clicks raw was my JSON stream, right? So I select clicks raw, create a new chart out of it, select say column called data because it's only got one column, it's JSON, right? It's not got that structure.
Mm-hmm.
Then I'm going to select my metric as say count star, right? Then create chart. It's going to make no sense, right? What is this? Why do you need this chart, right? So if you've got a JSON that you can make sense out of and create a dashboard out of, then you can probably do it. But yeah, I think you'd have to still structure it to create a dashboard that makes sense. Right? So
Even
this
for
makes no
the
sense.
KsqL, right? I think we are querying, we should have some kind of structured data to query upon.
Yes. So if you want to query it through KsqlDB, you should have structured data. How would you query unstructured data or semi-structured data? You would have to use other libraries to do that. Maybe pandas, maybe something else. But yeah, that's not it for KsqlDB.
Okay.
Both the consumer groups, including in this case the materialized and KSQL can stream from the consume from the same broker in Kafka, right?
They can consume from the same broker. Yes, I believe yes. They can connect to the same broker and consume from the same topic. Yes.
Okay. Thank you.
I just want to know one thing. I'm totally new to Kafka and also for this session. Thank you for this session. So I just would like to know, is there any place where everything is documented and I can just start by my own on my machine? I'm sorry. Yeah, please say.
Yes. You'll have documentations on Kafka's own website. So if you
Okay.
want to get started with Kafka topics, you can still
Okay.
create that. So you'll be able to understand it. If you can't, you can still reach out to
Okay.
me and we can figure out together.
Okay.
But thanks for joining, guys. Thanks for your time.